We're tracking an unusual situation tonight in Yellowstone National Park. Large numbers of animals appear to be migrating south. Yellowstone's valleys have been emptying fast. Elk, bison, deer, and even smaller animals are leaving in massive groups, heading for higher ground as if they're escaping from something. Hundreds of mountain lions have been leaving Yellowstone National Park, headed southward to Salt Lake City, Utah. Tourists are filming it and scientists are scrambling for answers. Because this isn't just any park. It sits on one of the most powerful supervolcanoes on Earth. A giant that could wake without warning. Is it simply migration or the start of something we're not ready for? Let's find out. The truth about Yellowstone's animal escape. In July of 2025, Yellowstone National Park became the center of a mystery you could watch unfold in real time. Elk, bison, deer, and smaller animals began leaving the valleys in large groups heading toward higher ground. Visitors filmed it, researchers documented it, and the videos spread quickly online. People everywhere began asking the same thing. Why were thousands of animals suddenly leaving Yellowstone? The concern wasn't just about the migration itself. Yellowstone sits on one of the largest active volcanic systems in the world. It hasn't erupted in thousands of years, but the same underground heat that powers its geysers and hot springs also fuels constant change beneath the surface. That's why big animal movements here make people pay attention. When wildlife shifts in large numbers, some wonder if nature is warning us before something bigger happens. Recent months had already brought an increase in small earthquakes and subtle ground changes. None were serious enough to trigger official alerts, but enough to catch scientists' eyes. Some biologists believe the shaking nudged animals away from usual feeding grounds, pushing them to cooler, safer areas. Others think they might be sensing changes humans can't, like tiny vibrations, trace gases, or small temperature shifts. Officials told the public there was no reason to panic. But they still launched close monitoring. Teams of biologists, geologists, and rangers began tracking where the animals were going, how fast, and in what numbers, hoping to pinpoint what had changed. Soon, something else caught people's attention. A slow-growing bulge under part of the park. Regular watchers of Yellowstone's live cameras claimed they could see a dome-shaped rise that had been forming for months. They compared older and newer images and said it looked more obvious now. One theory was that magma deep underground was pushing the surface upward, something that can happen before volcanic eruptions. Another idea was that the park's hot water system was building pressure, which can also push the ground upward. But because the shape stayed so steady, many thought magma movement was the more likely cause. That's the fear nobody likes to say out loud. If magma is pooling, the risk of an eruption gets higher. It could be a small local blast of ash and lava, or in the worst case, an event big enough to send ash high into the atmosphere, block sunlight, disrupt farming worldwide, and cool the planet for years. Even a smaller eruption could destroy wildlife habitats, damage towns, and overwhelm hospitals with breathing problems. Then came a burst of earthquakes. Tourists caught a blast near a hot spring that sent people running off a boardwalk. Biscuit Basin was shut down while geologists looked into it. Some people online claimed certain quakes weren't showing up on public records and even pointed to a supposedly unreported magnitude 2.4 event. That sparked talk. Were officials hiding data to avoid panic, or was this just normal for such a geologically active place? A leading scientist calmed fears, explaining that the quakes were within Yellowstone's usual range. The park averages about 1,500 to 2,500 earthquakes each year, often 100 to 200 per month. The crust here is thin, heat is intense, faults are common, and groundwater is always moving. That combination creates many small quakes, most too weak to feel. Still, the unusual wildlife migration kept eyes on the park. Some animals are known to sense environmental changes before humans. Things like shifts in electric fields or gas leaks. Yellowstone has also shown plenty of recent activity. In the last 2 years, it has displayed 2 of the 3 most common eruption warnings. Increased earthquake activity and more surface gas vents. New erupting vents and surface cracks even closed part of a boardwalk in the upper Giza Basin. None of this meant an eruption was certain, but it was enough to keep watch close. So, how do scientists actually keep watch on a system this big? Over 50 seismometers detect earthquakes and movement underground. GPS stations, satellites, and borehole strain meters measure even the tiniest changes in the ground's shape. They also test water and gas from geysers and vents for changes in carbon dioxide, sulfur dioxide, and hydrogen sulfide, which can show what's happening below. Satellites scan for heat and emissions across the park. This data helps officials decide when to close areas. issue warnings, or prepare for emergencies. Recent studies have given scientists a better view of Yellowstone's underground system. Using seismic tomography, like a CT scan of the Earth, they found a huge lower crust reservoir of partially molten rock big enough to fill the Grand Canyon many times. Above that is a smaller upper chamber, and deep below is a mantle plume bringing heat from far inside the planet. Most of this rock is solid with pockets of melted material, but knowing how heat and magma move helps improve eruption forecasts. Earthquake swarms have a long history here. Most are small and over quickly, and many go unfelt. Past swarms in the 1980s near Hebgen Lake and in 2008 near Yellowstone Lake gave scientists valuable data. These swarms are often caused by stretching crust, moving faults, shifting magma, or hot water carving new paths underground. While they rarely cause eruptions, visitors and locals are always advised to secure heavy objects, keep emergency supplies ready, and know how to stay safe during quakes. Strange animal movements aren't just random. They've been nature's alarm bell before. And in 1980, that bell rang loud around Mount St. Helens just before it exploded. The day Mount St. Helens erupted. In the early spring of 1980, Mount St. Helens in Washington looked calm and harmless under its snow-covered peak. Elk grazed in open meadows and the summit stood quietly against the sky. That peace ended on March 20th when a magnitude 4.2 earthquake shook the mountain, breaking 123 years of silence. Just a week later, it sent out steam and ash for the first time in a century. From then on, the volcano stayed restless. Quakes rattled it daily. Steam bursts rose from the summit, and its slopes began to change in ways no one could miss. The biggest changes happened on the north side. Scientists used reflectors and lasers to track movement and saw the numbers spike. A bulge was growing outward at about 5 feet each day, and by mid-May, parts of it were over 450 feet taller than they had been the summer before. This was a clear sign that magma was forcing its way in, building dangerous pressure. From March to mid-May, there were about 10,000 earthquakes. Instruments also picked up steady vibrations that show fluids moving underground. As this went on, locals began noticing wildlife acting in ways that were far from normal for springtime in the area. Elk and deer, which usually stayed in certain high meadows during that season, were showing up in valleys and lowlands they normally avoided. In some cases, whole herds were grazing close to roads or moving through farmlands, something residents said they rarely saw. Bird activity also shifted. Certain groves that were usually filled with constant birdsong had gone strangely quiet, while other areas seemed to have unusually large flocks gathering together. People living near the mountain talked about hearing fewer woodpeckers and songbirds in the forested slopes closest to the crater and instead seeing more of them farther away toward calmer ground. These were not official wildlife surveys, but they matched what scientists would expect when an animal's home range is shaken, blasted with steam, or filled with strange smells from volcanic gases. The changes suggested that the animals were instinctively moving away from the parts of the mountain that were becoming unstable, responding to things they could sense like tremors, vibrations, or shifts in air quality, long before humans could measure them. At 8:32 on the morning of May 18th, a magnitude 5.1 earthquake struck beneath the bulge, and all hell broke loose. In seconds, the entire north side of the mountain gave way in the largest landslide ever recorded on Earth. That sudden collapse unleashed the massive pressure that had been building for weeks, and the volcano erupted sideways. A roaring blast of hot gas, ash, and rock tore north at hundreds of miles an hour, and within minutes, a towering ash cloud was climbing into the sky and beginning its journey across the country. The lateral blast destroyed about 230 square miles of forest. Trees near the crater were reduced to stumps, while those farther out were blown flat, all pointing away from the volcano. Lava fast-moving mud flows tore down rivers, destroying bridges and filling channels with logs and debris. Towns downwind were plunged into darkness at midday as ash covered streets and rooftops. Wildlife in the blast zone stood no chance. Officials estimated nearly 7,000 large animals, elk, deer, and bears were killed along with most small mammals and all birds nearby. Fish hatcheries were wiped out and wild fish faced blocked debris-filled streams. Animals that had moved away before the eruption helped repopulate the area. Gophers, amphibians, and other creatures that survived underground or underwater helped restart the ecosystem when the ash cooled. The human toll was also heavy. 57 people died, many outside the strict closure zones because the sideways blast reached farther than expected. More than 185 miles of roads and 15 miles of rail lines were damaged or destroyed. The eruption also wiped out 4 billion board feet of timber. Damages were estimated at about $1.1 billion in 1980, and Congress approved $951 million in relief. Cities like Yarka spent weeks and millions of dollars clearing ash. The eruption left serious engineering challenges. Spirit Lake's outlet was buried, creating a flood risk. In 1985, engineers built a drainage tunnel through a nearby ridge and later constructed a sediment dam on the North Fork Tout River. These, along with regular dredging, still protect communities downstream today. Recovery began surprisingly fast in sheltered spots. When the snow melted, green plants emerged. Lupine spread quickly, adding nutrients to the soil and helping other plants grow. Spiders arrived on silk threads. Insects explored the new ground and gophers mixed ash with richer soil. Elk and deer returned, feeding on the fresh growth. What had looked like a lifeless grey wasteland in 1980 showed green within a few summers, giving scientists a unique chance to study how life returns after total destruction. Mount St. Helens stayed active. Between late 1980 and 1986, a lava dome grew in the crater in several phases. In 2004, another dome began forming and grew for more than 3 years, splitting the crater's glacier before it joined again below. These smaller eruptions gave scientists valuable data on magma movement and allowed them to test new monitoring tools like GPS, advanced seismometers, and all-weather cameras. One clear lesson came from the animals. Instruments can track quakes, ground swelling, and gas changes, but wildlife often reacts in ways that confirm the danger. In 1980, animal movements matched the scientific data showing rising magma and pressure. Animals often survive farther from eruptions and help restore life, and their behavior can serve as early warning signs. After Mount St. Helens erupted in 1980, U.S. volcano monitoring transformed. Observatories, sensors, GPS, cameras, and gas detectors now track threats, while flood control systems and education programs prepare communities. In 1991, Mount Pinatubo in the Philippines gave another lesson. Once a quiet green peak, it showed warning signs in April: ash bursts, gas emissions, earthquakes, swelling ground, and animals avoiding low areas. Scientists from PHIVOLCS and the USGS quickly set up monitoring networks. Rising sulfur dioxide levels and quakes confirmed danger, leading to mass evacuations. On June 15, Pinatubo exploded with one of the century's largest eruptions, blasting ash 22 miles high. Pyroclastic flows and Typhoon Yuna's rains collapsed thousands of buildings. Over 800 people died, but tens of thousands were saved by early warnings. Ash clouds cooled Earth by half a degree for nearly 2 years. Lahars then plagued the region for years, but forecasts, dikes, and resettlement reduced further loss, and the land eventually recovered. By contrast, Colombia's Novato del Ruiz eruption in 1985 showed the cost of ignored warnings. Lahars buried Amaro at night, killing more than 23,000 despite clear alerts. Survivors recalled animals fleeing danger before humans acted. Together, these disasters prove the same truth: monitoring, communication, and even listening to animals can save lives. Ignoring the signs can turn warnings into catastrophe.